Hi and welcome to this video for the BTEC Applied Science Unit 5. So what we're looking at here, combustion of alkanes. It's a fairly straightforward topic. Being able to predict products of complete and incomplete, do some equations with it, generally just getting them balanced correctly. So when we've got complete combustion, so I'll use C6H14 with this. Products of complete combustion are carbon dioxide and water. So with this, the key thing is usually just getting it balanced correctly. These two you should be able to rote recall. What's meant by complete combustion is that there is sufficient amount of oxygen to fully burn everything. So you're usually looking at an excess burning things nice and fully in a good atmosphere. Now, for balancing these tips to help speed them up for you, first off, balance your carbons. 6 on the left, so CO2, I'm just going to multiply by 6 there, 6 on the right, done. Hydrogen's next. I've got 14 here, there's 2 in every water, so just do 14 divided by 2, 7 there. So 7 times 2, 14, that's that balanced. And then finally finish it off with your oxygens afterwards. So we've got 6 times 2 here, and then 7 times 1 there. So together that gives us 19. 19 divided by 2 gives us 9.5 O2s there. If you wanted to, you're perfectly fine doubling everything up here, by the way, to having the 2, 19, 12 and 14. But it's usually easier just to have the half if required there. So complete combustion, you should know obviously issues with this in terms of it's a greenhouse gas. And hence we've got significant environmental problems going on through your lifetime that we need to get solved with this. Now, incomplete combustion. So this is where we are not going to have enough oxygen to burn the carbons fully and get the CO2s. So I'm just going to change our alkane up a bit. We'll go to butane. Now, you've got two options with this, depending again on how much oxygen there actually is. You can either get carbon monoxide and water, or carbon and water. More than likely, you'll get a bit of both, actually, I'm saying, or you'd get a bit of carbon, bit of CO, a bit of water. But for the sake of balancing the equation, just pick one or the other. The question may sometimes hint at it and say gaseous products only or a solid product. So if it's saying one of those, then obviously it's telling you which one to go with. So what we'll do is we'll just practice balancing them both out here. Again, carbon first. 4 there, 4 straight away. Again, 4 and 4 there, nice and quick. Hydrogen's 10. 10 divided by 2, so I just stick 5 in front of the waters. Now the oxygens, so obviously 4 oxygens there, 5 there, so 9 in total here. 9 divided by 2, 4.5. Whereas down here, no oxygens there, 5 there, 5 divided by 2, so thus 2.5 with that. Now, that's with the alkanes. I'd say be careful, it's not strictly said in the spec here, but just in case they chuck an impurity in there. So, for example, if I said something like the complete combustion of C5H12 H11SH. So where we've got a bit of a sulfur impurity in there, then what you would get from burning things like the sulfurs, the nitrogens, typically you'd get the sulfur dioxide, the nitrogen dioxide, in the same way that you get the carbon dioxide. So we'll do one here with this, just on the odd chance that it pops up. Again, CO2, H2O, and because we've got a sulfur, we need an SO2 in there. Sulfur is 1, 1, fine. Carbon, 5, 5 in front of here. Hydrogens, 12, 12 divided by 2, 6. Now add up your oxygens to 10, 16, 17, 18. 18 divided by 2, 9, done. So balancing them will become quite quick if you just follow those steps with that. Now, understanding the importance of combustion, well, our entire economy is pretty much reliant upon it in terms of the fossil fuels we use, for cars, factories, everything like that. So, yeah, very important, and we're probably going to destroy the planet with it and make David Attenborough cry, unless we get switched over to an alternative form of energy soon enough. But yeah, there's enough doomsdaying for this video. Thank you.